So the boom is at 60 degrees. Thank you. So Eve, you're the foreman. We want to show us the hand signals to raise the load. Okay? Keep going. Stop. Lock it off. Good. And it's... Okay, it's tipping over, right? Good. Okay. Lower the load before we have trouble. Thank you. Lower it all the way to the ground. Good sound effects. Okay. Now. Perfect. Okay, so there's the crane. How long is the boom?
It's 40 inches.
And the weight of the crane?
It's 18.75 pounds.
And the distance from the center of gravity to the pivot point?
Is 10 inches.
So over here, we got those numbers. Wait a minute. So we got the numbers. Weight times distance, right?
Yes. Weight times distance equals torque. And the weight of the crane is 18.75 pounds times 10 inches from the center of gravity to the pivot point. So if you multiply those two to find the torque, your answer is 187.50 inch-pounds.
Okay, now let's show me the other side of the equation. The load is 9 pounds up there. Okay.
2 bricks.
And now how do we find the distance from the center of gravity of the load to the pivot point?
We'll take the long side if it's at 60, 30, 90.
Right.
And
The shortest side.
Yeah, the shorter side is always half of the distance of the longest side.
Good.
And half of 40 inches is 20 inches. So then
Beautiful.
you multiply 20 times 9, or 20 inches times 9 pounds, and we get 180 inch-pounds.
So we got 180 inch-pounds on one side. Now, what about the, now we forgot to include the boom. The boom weighs 4 pounds. Where is it? 4 pounds.
Right there.
And how do we figure out, so that's the weight. How do we figure out the distance?
Well, it's going to be in the middle of the crane because both sides would weigh the same.
So the center of gravity is 20 inches
Right here, from
from the pivot point. Good.
If you draw a line here, that is 10 inches.
Wait, show me, let me look at that other triangle over there. Move back, let's see. So the distance from the center of gravity to the pivot point is 20 inches.
Yeah.
So now we have another triangle there, another 30, 60, 90?
Yep. And
Show me.
So we need to, so the center of gravity is right here, so we measure the distance from here to there. And
Good.
It's 10 inches.
Good, because in a 30, 60, 90 triangle, the short side,
Is half of the long side.
good. So the distance is 10 inches, and the weight is 4 pounds. So what, tell me, give me the numbers. Go ahead.
So, if the boom weighs 4 pounds, and the distance is 10 inches, 4 times 10 is 40, so the answer is 40 inch-pounds, which is added to the 180 inch-pounds that we already have, which gives us 220 inch-pounds,
And
which
that's
is more than
that.
the
So
100.
that's why it's
That's why it tipped over.
Yes.
So now we have to figure out how much counterweight we need and where to put it. So we need counterweight to keep it from tipping over. All we got is 1 brick. So why don't you put it in the crane someplace in the middle there. Okay. Let's lift up the load and see if it's going to work. Foreman? Okay, that didn't work. Okay. Any ideas? Madison, what can we do?
We could put the counterweight farther out, at the very end.
Okay, let's do that. The distance will be greater, yes. And if the distance is greater,
The torque is greater.
beautiful. Okay, Foreman. good. So it worked.
Yay.
Let's see if the numbers tell us why it worked. So we're going to measure from the center of gravity of the counterweight to the,
29.5.
can we call it 30?
Yeah, sure. 30.
To the pivot point, it's 30 inches. Okay, Ben, so we added, we added one brick, which is 4.5 pounds, and the distance from the center of gravity of the brick to the pivot point was,
30 inches.
okay, weight times distance, show me the,
The weight times distance equals torque.
okay, so we had 4.5 times 30 is,
4.5 times 30 is 135 inch-pounds.
so we added that to the 187, which was the crane,
Yes.
and we got,
332.5 inch-pounds.
which was a lot more than the 220.
Yeah.
And it's probably enough that it fulfilled the safety factor we had.
Yeah.
Okay, so it didn't tip over.
That's why the counterweight worked. 'Cause-
Exactly. Now, if we, let's say we didn't have the counterweight, we had to lift the load. We couldn't, the load was still 2 bricks. We couldn't change that, and we had no counterweight. What could we do to be able to lift the load?
Lift the boom.
Raise the boom
Yeah, it's
to a higher angle?
Yeah.
Let's try that. Yeah, let's try that. Okay, we raised the boom. Now we don't have the counterweight. Now let's see, we're gonna lift the load. And didn't tip over. It worked. So if we don't have a counterweight, the solution is to raise
The boom.
So when we raise the boom, the distance from the load to the pivot point gets shorter. So if the distance is shorter,
There's less
less torque.